Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Calm Construction by Oscode. And here are the rules. We have Sudoku, where we need to fill all rows, columns, and marked 3x3 boxes with the digits 1 through 9 without any repeats. We have Chaos Construction, where we need to divide the grid into 9 additional regions of 9 orthogonally connected cells. And each extra region contains the digits 1 through 9 without repeats. So in addition to normal Sudoku rules, we also have chaos construction rules on top of it. And what does it mean to make a region of 9 orthogonally connected cells? Well, I'm glad you asked. It's basically, you have to have a region where basically to go from any cell in that region to any other cell in that region, it must be able to go through edges only, all while staying within the region. So to get from this cell to this cell, you can go through these edges, all while staying within the region, and get to that cell. So this is a valid example of an orthogonally connected region. This is not, because to get from this cell to any other cell in the region, you'd have to go through a corner or get outside the region, which is not allowed. And same with this. These two cells can get to each other through a edge, but to get to any other cell in the region, they would have to go through a corner or go outside the region. And that's an example of how chaos construction works. And we also have circles, where a digit in a circle indicates how many cells, including itself, overlap between its 3x3 box and its additional region. Interesting. So it technically could be 9 if the box is the same as the additional region, right? So say this, okay. Say this was the region, a region in the puzzle. Then this cell, well, all 3 of these cells would have to be 5, because the overlap between the additional region each of these circles is in, plus the 3x3 box that the circles is in, would have to be 5, because we have 5 cells which are in their region with the circle and in the 3x3 box that the circle is in. So that should tell you something. These would be 2, right? Because there's 2 overlaps within the 3x3 box for the circle here and the region that it's in, right? So that should tell you something there also. This would be 2 also because, again, the 3x3 box it's in is box 5, and there's only 2 cells in the green region, which it's also part of. So that's an example of how the circles work. Obviously, this cannot be a valid region because of that. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So because of what we found out, circles in the same 3x3 box cannot be in the same region as each other, right? Because if they are in the same region, they would have the exact same amount of cells in their 3x3 box and the additional region. So these have to be different cells. So we can draw boundaries around between them then. So these are different regions. This has to be a different region. This is a different region, different region, different region, different region if they're in the same box. Okay. Obviously, the edge of the grid is a region. So this we're going to mark as... do we mark it as green or red? Let's mark it as green. We're going to mark this as green. It has to go here to extend out to get 9. This has to extend out here. We'll make that medium. will make light. This is probably medium. This will make dark, and this will make orange. So orange has to go at least to here. So this is a region. Okay. So the 3 digits can only add up to 9 at most, right? Because there has to be 9 cells at most within a region. So this is at most 1, 2, and 6. This has to be at least 3. So this is 3, 4, 5, or 6. This is at least, this has to be at least 3 also. Interesting. So this is at least 3 here, because this has to go out of the region. This is at least 3. So it could be 3 through 6. This actually cannot be 3 through 6. If it's 3 through 6, the problem is, yeah. This has to be at least 3 regions to get 3 cells to get outside of the box. And it has to get outside the box because otherwise it doesn't form a full region otherwise. So this is at least 3. So this has to be 3, 4, 5, and 3, 4, 5 here. And that means as a region, this must be, one of these must be 3. Because if it's not a 3, how is that going to form a set of 9? It can't, right? So this is 1 or 2 with this. This has to be 3 to form a region, period. Because it has to share. This has 3 at least. This has 3 at least. And it cannot be 3 because one of these two has to be 3. If you have 3 digits, unique digits, adding up to 9 or less, you're guaranteed at least 2 of them have to be from 1, 2, or 3, right? Because if you have 6, if you have 3 digits adding up to 6, it's 1, 2, and 3 guaranteed. If you have 3 digits adding up to 7, it's 1, 2, 4 guaranteed. If you have 3 digits adding up to 8, it's 1, 2, 5 or 1, 3, 4, both of which require 2 digits from 1, 2, and 3. And if it's 9, if they add up to 9, which is the maximum these circles can add up to, it's either 1, 2, 6, 1, 3, 5, or 2, 3, 4, all of which require 2, 3, and 4. So 3 has to be one of these two, which means this cannot be 3. So that means this is at least 4. It could go something like that, so we don't guarantee that this is part of green. But this is 4, 5, or 6. This has to be 1 from 1, 2, or 3. It cannot be 3. So this is 1 or 2. And it has to be 2 here. At least. Because we already know 2 are in this box. So this is guaranteed to be 2. This has to be 1. So this is either, so this has to go this way. And it's likely part of the medium cell. We'll do that for now. Actually, let's just make it pink for now. Let's make it blue for now. Because we know this is a boundary, because only one overlap for the 3x3 box and its region. This is guaranteed to be 3, and it could be 4 or 5. This cannot be 1, because if this is just 1, the problem is this is not going to be a 9 cell region then. So this is at least 3, so this has to be 3 and this must be 4 then to be valid. That means this cannot be 4 here. This must be a 3x5 region. This is either 1, 2, 4 or 1, 2, 6. This can't be 2. So 1 has to be one of these two. So we have 1, 2, 4 or 1, 2, 6 here to add up to 7 or 9. This can't be 1 because it can't be a region by itself. It could be 2 though, but 1 has to be one of these. 2 has to be one of these. Remaining digits in, so this is done as a region here. So this has to go this way. It cannot have a 2 in it. So this has to be 6 as a region or 4 as a region at least. Remaining digits in row 1 are 6 through 9. This has 3. Can it ever go all the way around here for the green? And the answer is no, because then it would block the light as a region. So this must be light. Technically could go green here and then light here. That is possible. This has to be 1, 3, and 5. 1 can't be here. These all could be 9. We don't know. Can this ever be orange without the dark being here? Say it's 5, right? Yeah, it can't be. It would block the dark in. So this has to be dark at least. And this is either both dark or both oranges. We're not sure which. One of these has to be a 1, though. That's interesting. You could technically have 4. Okay. One is here, so that means 1 has to be one of these 3. 2 is here, so that means 2 has to be one of these 3. We have 3 here and 3 here, so 3 has to be one of these 3. So again, for 3 digits adding up to 9 or less to another single digit, you're guaranteed 2 digits from 1 through 2. 1, 2, or 3. And we can't have a 3 there, so this has to be 1 and 2. That's the reasoning for that. 3 has to be here. 5 has to be here. So where's 5 in row 2? It has to be one of those 2. Because it can't be here because this is a 1, 3, 5 triplet. This blue has to be, cannot be 2. If it's just 2, the problem is that it would not be able to form a 9-cell region. So it has to be 4 or 6. This cannot be 2 either, so this must be it. How does that work? This can't be 2 and this can't be 2. It has to be the same region. That's the reasoning. Okay, so that's the reasoning why we know this is the same region. This can't be 2. This can't be 2, but we know we have a guaranteed 2 here somewhere. So this actually must be the same region then, right? Because if it's just 2 here, this can't form a full 9-cell region because it's stuck. If this can't have a 2 here, so it has to have 4 or 6 as the region for here, and it therefore has to be the same one. So these are all the same. It can't be 4. If it's just 4, it goes out here or it has to go out here, and that's not allowed. So this has to be 6. So this is not 1, 2, and 4. This is guaranteed to be 1, 2, and 6, which eliminates 1, 2, and 6 in the rest. Ooh, that makes that a 6. That's not... That doesn't work. Oh, it could be 1, 2, 5. It has to be 1, 2, 5 then. Okay. Right. I totally forgot that it could be 1, 2, 5. So this has to be 1, 2, 5 then. Interesting. So this is not 124. That's not allowed. It could be 125, and it has to be because we have a guaranteed 6, 7, 8, 9 here. Okay. So this is 125, which means this can't be 5. This can't be 5. We have a guaranteed 5 here. Can it be 5 going this way? Yes. It could be just 2 digits here. So it could be 5 going this way or 5 going this way with 2 going that way, and then 1 is a separate region. So that's possible. Okay. So we have 3 here and 4 here. So one of 3 or 4 is here. The other 3 or 4 has to be here. It cannot be part of these regions anymore because, again, we only have 2 cells in the 3x3 box that are in the region and part of this cell. Same with this. This is 1 cell that is part of this 3x3 box and part of the same region. So it has to be 5. There must be 3 and 4, and there has to be another 3, 4 here in one of these 3 cells. But it cannot be this cell, because if that were 3 and 4, that would mean 3 or 4 cells would have to be in that 3x3 box, which is obviously not possible. So this must be the other one, which makes this 3 and 4. So this must be 5, and this must be a 3, 4 pair. Okay. Which means this is full as a boundary here. This can't be 5. It has to be 2. This can't be 5 or 2. It's 1. So this must be with the dark gray region. This has to be 5 then, because it cannot be 3, because it can't go any further out this way. It's a boundary there. And it has to get 9 cells. So this is all dark, which makes this a 3. This is a 5. So this is part of the cell here. And it has to be at least 3 cells in this box to be to get out of the box. And it has to get out of the box. Well, it doesn't have to get out of the box, but it needs at least 6 more cells. So this is orange. This is 5 cells here. This is a boundary here because it can't go back here. This has to be 2 cells, so it has to exit out this way. And this is a separate region. It could be orange. 1, 2, no, it cannot be orange. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's too large. This can't be dark. This has to be some other region. So the 2 has to go out here. That means the pink has to go there. This is done as a region. Light has to go somewhere. If we tried going green all the way around, the problem is light wouldn't be 9 cells. So light has to go here and green has to go here. Okay, so light has to go out this way. This could add up to 9, but it has to be at least... It cannot have 2 and 3. You could have 4 and 5 here. This has to be greater than 3, so it's 4, 5, or 6. Because we only have 9 digits total, 9 cells in the region. This is done as a boundary. This has to add up to at most 8. Because we have another digit here, which is not part of those regions. One of these at least has to go out here. So this is 1, 2, 3, 4, 5, 6. This is separate than this region because this only has 1 cell in this region. 1, 2, 3, 4, 5, 6. 7, 8, 9 is guaranteed there. It cannot... I guess it could no, it'll block the yellow if that happens. Can this actually go this way? for a full set? I think the answer to that is no. So this has to be at least 3 or 4 because it can't be 2. So 3, 4, 5, 6 at most because this can never. Oh, this can't be 1 anyways. This is at least 2. 2 through 6 can't be 6. 2 through 5 here. Okay. This is light. It could be light here. It could be light here. No 2 and 3. Can this actually ever be 1? No for this. This would be either green or it's light. And either way, green has to expand further. So this is at least 4. This cannot be 1 either, because if it's just 1 by itself, that's not a full region. So this has to be a 4-5 pair here, guaranteed. Because none of them could be 1. So this is 4 and 5 as a pair, which eliminates 4 and 5 in the rest of the column. The 5 has to be the green, because the 4 cannot be green, and it's definitely part of this. So this is green and light, guaranteed. So this is green and light. We have all the greens are set. The light has to be 4 cells. So that means we have 2 more lights outside of this 3x3 box. We don't know where. Okay, this can't be light. If it's light here, that would block the green in. So this is definitely green. We have a 2, 3, 4, 5, 6 quintuplet in row 4, which eliminates 2, 3, 4, 5, 6 in the rest of the row. So we have what, 1, 7, 8, 9 remaining. We have a we have a 3, 4, 5, 6 quintuplet in row 4. So that eliminates 3 through 6 in the rest of the row, so this can't be 3 through 6. This is 2. Interesting. We know 3 has to be one of these. So this is only 2, which means it can go only 2 here, and then it must extend out. We are guaranteed a 3 here. So if we try to extend out here and then go there, that's not possible. Because then this would have 3 darks, and then we'd have 3 oranges, and this would have to be 3, which is not allowed. So this must be 4, which makes this 5, this is 3, and this is 6. Okay. So, and it has to be 2 yellows here. Again, we have to have 3 darks in box 6. We have to have 2 yellows at least in box 6, and therefore we have 4 oranges in the remaining cells. So this is all pink. These are the boundaries that have to happen. The yellow has to go to here because there's no other place for it. It can't stay in here more than 2 because we have 3 guaranteed darks and 4 guaranteed oranges. This is obviously dark, because if it's orange, that blocks the dark off. Dark has to go here, dark has to go here, so these are all oranges. So these are all boundaries here. This is a boundary here. We have 2 more cells for orange here. Okay. So we have 2 and 6 here. This is 1. 1 can't be in the dark region, so obviously one of these is a 1. This is 5, which makes this 4. So this is not light. This is green. This is not green, so this is light. The green has to go out this way. So this is green. This is green. This has to be green because the green can't... All 5 of the remaining greens have to go in box 4. So this can't be green. This is light. Light has to go out this way then, because we have 7 cells only for the light region. So this is done this way. We are guaranteed a 1 in the light region. We are guaranteed a 1 in the green region in these cells, because 1 has to be here and 1 has to be one of these two, because 1 can't be here. We have 8 light cells. So green is done. We have 1 more light cell. Green has to have a 2 somewhere in its region, and it cannot be here. It needs a 2 and a 3. 2 and 3 can't be here, 2 and 3 can't be here, 2 and 3 can't be here. So 2 and 3 have to both be here. We need a 2 for the light region. It could be any of these. We have 4 already. So 4 cannot be here because that's in the light region. So 4 in column 3 has to be one of those 2. We need a 2 in one of those 3 in column 4. This is 3, so this must be 4, which eliminates 4 in the rest of these regions. Yellow needs access to a 1. Okay. This becomes a 2-3 pair. Huh. Where are 2 and 3 in column 3? Cannot be here because of the 2, 3 in the box. Can't be here because of the green requiring 2 or 3. So there has to be a 2 and a 3 here. So 4 is here because 4 can't be any of these cells. It can't be in the light region because of a 4 in the light region. Can't be in any of these cells. Can't be here because of 4 in the box. So 4 is here. 3 can't be here for the same reason. So this must be a 3-4 pair here. Where is the 2 then? In column 3. Can't be here because of 2 in the box. Can't be here because of the 2-3 pair in the box. So this must be 2 here. Which means this can't be 2. This is a 3-4 pair. The light cannot go down here. The light could go here. Or the light could go there. We don't know which. So this is definitely a boundary here. This can't just be one cell. Can't be 2, 3, or 4. It could technically be 5 through 9. Not 9. 5 through 8 here. Because if it's 9, it would have to have all 9 cells in that box, which is not possible. This cannot be 9 either. Because we're missing 1 from the yellow, at least 2 from the oranges, so this is at most 6. And it has to get out. Cannot be part of orange. So can't be 2. It has to be at least 3 or 4. So this is 5 or 6 here. Okay. The green needs access to a 5. Cannot have 5 here. No 5 here. No 5 here. So 5 has to be here, which means this can't be 5. The light needs access to a 5 also, but it doesn't have access to a... Oh, wait, no. Green already has a 5. There we go. So this can't be 5. There we go. So 5 has to be here, which means 1 has to be in the green region, which means this cannot be 1. Okay, there we go. Which forces this to be a 1 here. Okay. So that's 1. The remaining digits in box 1 have to be 1, 6, 7, 8, 9. Obviously, 1 can't be here. 1 can't be here. Where's 4? 4 has to be in the dark region. So this is 4. The dark region needs access to a 3. 3 can't be here because of 3 in the box. So 3 has to be here. Which means we need access to a 2 in the dark region, so 2 has to be here. This can't be 2. We need 2, 4. So 2, 4. We need 6, 7, 8, 9 as the remaining digits in the dark region. And the 6 has to be one of these 4. 2 cannot be in the yellow region here, so 2 has to be in the orange region here. So this cannot be 2, 4, or 6. It has to be 2 digits from 7, 8, or 9. 4 has to be one of those two. One of these is 3. This can't be 1. Remaining digits in box 5 are 1, 4, 5, 7, 8. Obviously, 1 cannot be either of these. 4 cannot be any of these because this can't be 4. Where's 4 in box 5? It has to be here. So this is 4. This is 3 with 6, 7, 8, 9 here. Obviously, 6 and 9 cannot be here because of 6 and 9 in the column. This is 4 here. 5 cannot be... 5 is here. Remaining digits in box 4 are 6 through 9. We have one other digit for pink. This is guaranteed to be 2. 1 cannot be here, so this is also guaranteed for 1. So we have 1 and 2 here. Remaining digits in the box are 5, 6, 7, 8, 9. So this cannot be 5 because of 5 in the column. This can't be 9 because of 9 in the row. These can't be 9 because of 9's in the row. Three's here, which eliminates 3 here. So this must be 2, this must be 3. That means 2 cannot be here. These cannot be 5 because of 5 in the column, so where's 5 in box 5? It must be one of these two cells, which eliminates 5 in the rest of the row. So this is not 5. Four has to be one of these 3 digits here. Five is one of these 2 digits here. Okay. 2 cannot be here. 2 has to be one of these 2 digits in column. That's not true. Could be here. Or here. Okay. We're missing a 6 through 9 in the light cells. We're missing a pink cell in one of these cells. We're missing 2 orange cells here. Yellow, we're missing 3 yellow cells. We need access to a 1. So it must go either this way or this way. Excuse me. 3 has to be one of these 3 cells here. Remaining digits in column 4. 1, 2, 6, 7, 8, 9. Obviously 2 cannot be here. This 9 eliminates 9 here. So whatever this digit is here, let's mark it with the A, has to be one of those 2 digits here. So this is 3 and A here. A is here, so A cannot be any of these cells. A has to be one of these 2. Okay. These 2 cannot be the same as these 2, so it has to be, these 2 cells must be the same as these 2 cells. And these two cells must be the same as both of these. Okay. Huh. Hmm. 6 eliminates 6 here. This becomes 7 or 8. Huh. Okay. Hmm. This cannot be obviously the green, the light, the gray, the medium. Medium's already done. Pink, yellow, or dark or orange regions. So this is guaranteed to be red. This is guaranteed to be blue. For the same reasoning. It can't be these can't be the same region, right? You have 5 guaranteed here and 5 guaranteed here. That would be 10 if they were the same region, which is not allowed. Red obviously has to go out somewhere here, and it needs access to a 2. So it could be the full region here and then a 2. This has 5 or 6. And then it must go out. This has to be blue. Because, well, yellow, if it could extend there, but it would block the blue from being a full region if that's the case. Orange can only have 2 cells. So orange can go up to here. Yellow cannot go all the way down here because it would block the blue region. So yellow cannot go all the way here. Yellow could go here, here, or here potentially. Cannot go block the blue. Can't be 1, 2, 3 that way either. So 1, 2, 1, 2, 3, 1, 2, 3, potentially going that way. 1, 2, 3, potentially going that way. Blue could obviously be any part of these regions. Blue has to be here to extend out. If yellow goes here, that would block the blue, and that would be too small of a region. Blue could be all of this, actually, technically. Pink has to be one of these 3. Light is either here or here. Blue technically could be 5 here, and then 1, 2, 3, 4. Or 5. Well, this is always blue. Red could be up to 5. So any red could be any of these, technically. And then up to 5. Probably red there and blue there is possible. Right, 1, 2, 3, 4, and then you have 5 in this region. Interesting. So this has to be greater than 5. We have already 5 reds here. Red has to go out somewhere, so this is at least 6. And light can only be one other digit, right? We have 1, 2, we have 7 here already. This is the 8th, and we have a 9th in one of these 2 cells. Remaining digits in column 2, we have 1, 6, 7, 8, 9. Remaining digits in column 1, we have 1, 5, 6, 7, 8, 9. 5 has to be one of these two. Okay. Yellow again cannot cut off this way. If it goes 1, 2, well, it'd be 1, 2, 3 at most. It can't go 1, 2, 3. Can't, yeah. Yellow cannot go all the way there. That would be 1, 2, 3, and that would cut off the pink. So this is not yellow. So yellow could be 1, 2, 3, could be 1, 2, 3. Yeah, any combination of those. Orange has to be at most 2. What happens if yellow goes this way? 1, 2, 3. This would not be 5 or 6. It would just be 3. So yellow cannot go all the way here, because if it goes all the way there, orange must both be here, and this would then be 3 there. So no yellow here. What about yellow here? If we try to go yellow here, that'd be 1, 2, 3 yellows, 2 oranges, and blue would have to be 4 at most. So yellow cannot be here. Yellow could be either of these cells, though. Well, if yellow's here, this could be orange, orange. And then these would be blue. That would be fine. Where is 1 in the yellow region? 1 has to be either here, or it has to be one of these 4 cells. It has to be one of these 2, technically. So all of these cells see that cell there, so this cannot have a 1, because the yellow needs to have a 1, and it's either here or one of these 2 cells. Pink, we don't know what it has to include. It could be, so it's guaranteed to have a 1 here. But we could be missing 3, 5, 7, or 8. So we don't know which one's missing there. Light is missing 6, 7, 8, or 9. Red has only 6, so neither of these can actually be red. Because you could only have 3 more going that way or 3 more going this way. You cannot have a red go that way. That's too far. You could go 1, 2, 3 technically, or 1, 2. That seems fine. Blue could extend still there, because this could still be 5. Hmm. Red needs access to a 2, and it has to be one of these. Because it can no longer extend to here. Orange has a 2. Yellow has a 2. So the 2 in the blue region has to be one of these cells. Okay. What? Where? We don't know. Remaining digits in column 5, we have 1, 3, 4, 5, 7, 8. Okay. Interesting. Okay. Say this was a 5 here. Where would orange have a 5? It wouldn't, right? Because if this is 5, that eliminates 5 in the rest of the box, eliminates 5 in the rest of this column. 5 can't be here because of 5, so orange would not have access to a 5 if this were 5. So this must be 6 then, which eliminates 6 for the rest of orange in this box and this column. So 6 has to be here then. That forces this to be 6, which means none of these can be 6. So we have a 7-8 pair in box 4, which eliminates 7-8 in the rest of the box. So this is 9. This can't be 9 or 7-8. It's 6. The 7-8 pair also eliminates 7-8 here. In row 6, so this is 1. No 7, 6, 7, or 8 here, so it's 5. This can't be 1, 5, 6, 7, 8, so it's 2. That forces this to be 1 here, because there's no other place for it in the box. This obviously can't be 6 anymore. 5 in yellow eliminates 5 in the rest of yellow. These can't be 1 anymore. So, where is 5 in box 5? It has to be here. So this is 5. This is a 7-8 pair, which eliminates 7-8 in the rest of the row. This can't be 7 or 8. It's 9. So there's no 9 here. There's no 9 in the green region. There's no 6 here. So one of these two is 9. That's fine. That means 6 has to be one of these two, which means that can't be 6. This can't be 9 anymore. Okay. This 9 eliminates 9 in the rest of the row, or column, I should say. The 7-8 pair eliminates 7-8 in the rest of the dark region. So this has to be a 2, 4, 6, 9 quadruplet in box 3, which eliminates 2, 4, 6, 9 in the rest of the box. So it can't be 2, 4, 6, 9. This is 7 or 8. As a pair, this 3, 7, 8 triplet eliminates 3, 7, 8 in the rest of row 3, which eliminates 3, 7, 8 in the rest of that. Well, I already said that. This is 1, 6, which eliminates 1 and 6 in the rest of the column. This can't be 1 or 6 now. This has to be 2. This can't be 2 or 6. It's 9. That eliminates 9 here. This is a 4, 6 pair, which eliminates 6 in the rest of the column here. So this has to be 7 or 8. We have a 7, 8, 7, 8 pair in row 2, which eliminates 7, 8 in the rest of the row. So this is 9. This can no longer be 9 here. So this A actually matches with this A. Interesting. Which is matching with that A. This is a 7, 8 pair in row 1, which eliminates 7, 8 in the rest of the row. So this is 6 or 9 there. The orange needs access to a 5. And it cannot be 5 here, so one of these is 5. This is a 5-9 pair. The orange needs access to 9 also, so both of these are not blue. These are orange, which eliminates orange in the rest of the box. This blue means 6 of the cells in the blue region are also in the 3x3. So this cannot be yellow. This can't be yellow. So this is done as a region. This only goes 3. This has to be yellow because the yellow needs to exit out. And it can go to one of these. So that's 1, 2, 3, 4, 5, 6, 7. It could be 8, 9 that way or 8, 9 this way. The blue can no longer get to here. So none of these are blue. Therefore, this is 7 or 8. Cannot be 6 because both of these are red. The 6 eliminates 6 in the rest of the row, so no 6 here. This is a 5-9 pair. This 6 eliminates 6 here, so that's 4 and 6. Remaining digits in column 8. We have 1, 2, and 7, 8. So, and this can't be 2 because of 2 in the row. So we're guaranteed a 2 here. We have 1, 7, 8. Remaining digits in column 7. We have 3, 4, 7, 8. And yeah, 3, 4, 7, and 8. This cannot, well, it could be 3. Digit here. So we definitely need access to a 1 for the yellow. 1 cannot be here, 1 cannot be any of these. So we're guaranteed a 1 here, which eliminates 1 in the rest of the column. Or rest of the box, I should say. We're guaranteed one of the 1s here. So we have 3 here, and we have 4 here. 4 is one of these 3. 1 has to be one of these 2. Remaining digits in column 6. We have 3, 5, 6, 7, 8, 9. Obviously, 6 cannot be here. This can't be 5 or 9 because it's in the yellow region. This 5 eliminates 5 in the rest of the column. So 5 has to be one of these 2 digits here. Blue needs access to 5 and 9. 1, 2, 3. If we did 1, 2, 3, that would block the yellow. Okay, so one of these has to be yellow. We have 1, 2, 3, 4, 5, 6, and then we need 3 more here. So if we tried to go blue, blue here, that would block definitely one of them. You could go blue, 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 possibly. Or blue. So either of these could be blue, but it cannot be blue, blue, blue. It can't be blue, blue, blue. So this can't be blue, this can't be blue. Blue cannot get there. Red is 7 or 8. So red cannot reach here. So blue has to include there. So that's 1, 2, 3, 1, 2, 3, 1, 2, 3. So blue can never reach there. So this is red. Either this is 2 or it's the same digit as that. Blue's missing 5 and 9 and whatever digit is there. Okay. Yellow's missing 1, which is why we knew one of those is 1. What else is it missing? We don't really know. Obviously a 4. But it could be having the 4 there, right? Okay. Light is missing a 7 or 8. And it's missing the A 7 or 8. So light cannot be here. If light were here, the only possibility for the A would be here also, but we know this is guaranteed A for this cell. Because green does not have access to an A except here. right? These are all filled out. This can't be A because of A in the box. This is a 1-6 pair. So A has to be here, which means light cannot go this way. Light has to go this way. And it's A. So this is A. We're going to mark the other one as B. So B, B. This is A, so this must be B, which means this can't be B. That's A. So A is here, which means this cannot be A here. Therefore, this is a 3. Therefore, this is not 3. This is A here. This is B. This is a 7-8 pair, which eliminates 7 and 8 in the rest of the column. So this is 1, 3, 4 triplet, which eliminates 1, 3, 4. Well, light goes here. So where is pink? Pink has to go here. So this is pink this way. And it must be a 3 because pink does not have access to a 3 anymore. Therefore, none of these can be 3. This 3 eliminates 3 here, so that's 4, which eliminates 4 here, so that's 1. The red has only 8. So therefore, this must be red. This cannot be red in any of these spots. So this must be all blue. These all have to be all yellow because there's no other place for it without cutting off the blue. So then this is the region. 4's here, which eliminates 4 in the rest of the blue region. And we need 5 and 9. So this is 5 and this is 9. And this makes that 2. So this is done as a region. This is A. We need a 4 in the yellow. It has to be there. And this can't be 3, 5, or 9. So it's 6, 7. So B is one of these two. This is 4. This has 3. 9 eliminates 9 here. This 8 eliminates 8 in the rest of the box. This 8 forces B to be 7. So we know B is 7. We know A is 8. So these are all 8, which eliminates 8 from being here. So this is 8, which means this can't be 8 here. This 1 and 2 eliminates 1 and 2 here. This 8 eliminates 8 here, so this is 7, which makes this 8, which makes that 7. 7 eliminates 7 here, so it's 1. 7 eliminates 7 here, so it's 6 and 7. That leaves this as a 2. 1 eliminates 1 here, and this can't be 7 because of 7 in the row. So we're guaranteed one of these is a 6. This can't be 6 or 1 or 7, so it's 9. The 9 here eliminates 9. This can't be 7 or 8. It's 3. 3 eliminates 3 here, so it's 4 and 3. 9 here eliminates 9 here, so it's 5 and 9. 9 eliminates 9 here, so it's 6 and 5. 6 eliminates 6 here, so it's 1 and 6. This can't be 5 or 7. It's 1, which leaves this as a 7, and that leaves that as an 8. 6 eliminates 6 here, so it's 9, and that's a 6. We're still missing ones. This is 8, eliminates 8 here, so it's 7 and 8. And that's the solution. Yeah, fairly straightforward. Yeah, not too bad. This would be less challenge. I think this is not quite hard for me. It's slightly more difficult than challenging, but not really that much more difficult. So, I think it's appropriate to label it as hard, but it's not hard difficulty for me. Seemed very straightforward, actually. A lot of really cool interactions with these circles. These were used by NXT Master to create his deconstruction puzzles, which are actually very interesting. So that was a interesting part. But instead of deconstructing, this puzzle basically uses normal Sudoku with chaos construction, which is a very interesting mix. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.